Let's look at Google's PageRank algorithm. This is a brief summary of Google's PageRank, the algorithm it uses in its search engine. Initially, Google constructs a set of several hundred sites. Then it constructs what's called an adjacency matrix A. Okay, so here, for example, let's say we do a search for, I don't know, Taylor Swift. So these are the referencing sites, and these are the sites that are referenced. Here, A sub ij is 1 if site 1 references site j and 0 otherwise. So we're going to look at which websites cite other websites. Thus, site 1, okay, this is 1, 2, 3, 4. Site 1 references both sites 3 and 4. Okay, it does not cite itself, of course, and site 1 does not cite 2. A hub references many other sites, and an authority is referenced by many sites. Which of the 4 sites is the greatest hub? Well, that would be the one that references many, many sites, and in this case, that would be site 4, because site 4 references 3 sites. Which of the sites is the greatest authority? This is the one that is referenced by many sites, and in this case, 1 is the one that's referenced. Everybody references 1, so 1 is the greatest authority. So the above can be calculated in this way. Rather than actually count 1, 2, 3, you could just do it numerically. The hub vector h0 tells us the row sums of A if we let h0 equal A times 1, 1, 1, 1. So here is our vector, here's our matrix A, multiplied by 1, 1, 1, 1. And notice what we get. When we multiply this row by this column, we basically get the sum of the entries in the row, which in this case is 2. This row times this column gives us 1. Dot product of this row and this column gives us 2. And the dot product of this row and this column gives us 3. So 2, 1, 2, 3 tells us the row sums. The authority vector tells us the column sums of A. So this will help us to figure out which is the greatest authority, which one gets referenced the most. We let A0 equal the row vector 1, 1, 1, 1 times A, and then take the transpose. In this case, 1, 1, 1, 1 times our matrix A. Well, let's see. This is a 1 by 4 matrix. So you take this row and this column. Let's see. And when you do that, you end up with 3. Take the dot product, you end up with 3. Dot product of this row and this column gives you 1. This row and this column gives you 2. This row and this column gives you 2. Okay, so you end up with 3, 1, 2, 2. But if you want a row vector instead of a column vector, you would just take the transpose. Okay, so again, this formula enables us to figure out the column sums so that you can determine which is the authority, which gets referenced the most. But when we determine which site is the top hub, like we did a few minutes ago, we should not just count the number of sites that it references. Some references should carry more weight. For example, since site 1 is the greatest authority, look, 3 people cite it. Since site 1 is the greatest authority, more weight should be given to the hubs which link to it. All 3 sites reference site 1, so each hub that links to it gets a score of 3 for doing so. So this leads to a new and improved hub vector. Again, look at the score, 3, 1, 2, 2. 3, 1, 2, 2. So we are going to weight these websites. So again, this is our new hub vector, and it depends, because hub 1 has the greatest authority, site 1 has the greatest authority, that one gets a weight of 3, this has a weight of 1, this has a weight of 1, this has a weight of 2. So we have this weighted, new and improved hub vector, 4, 3, 5, 6. And notice, in this case, and actually, here's the way you can calculate it. This is our vector A, okay, not our vector A, our matrix A. And this is our A0, so it's just a matter of multiplying A and A0. And we end up with 4, 3, 5, 6. Now, some books have H1 equals A0 divided by the length of A0. They divide by the length of the vector so that H1 has a length of 1. Oh my goodness, if life isn't so complicated already, that step's not necessary. It complicates the calculation, so we won't do it. Okay, so similarly, again, what we just calculated is this new and improved hub vector. And it looks like the best hub is 4, next is 3, next is 1, and then Yeah, sorry. So it looks like the best. So it looks like this is the best hub, and this is the second best hub. This is the third best hub, and this was the last. It's bringing up the rear, the worst hub. Okay. Similarly, when we determine which site is the top authority, we should not just count sites which reference it. Some sites should carry more weight. For example, since site 4 is the top hub, we just saw that a moment ago, if it's the top hub, then more weight should be given to the authorities that it references. Now, under the new hub vector, site 4 gets a 6. We saw that a moment ago. Okay, so each authority that it links to gets a score of 6. Again, we're ranking, we're ranking authorities, and what matters is who regards you as authority. Since 4 is, oh my goodness, 4 is the mother of all hub vectors, so that one gets a 6. You get a score of 6 because you're the best hub vector, or you're the best hub. Okay, so our new authority vector is going to be A1 times, it's going to equal 4 times this vector, blah, 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 4 times this vector, 5 times this. Again, this is because website 4, has that hub score of 6. And so everything that 4 cites, everything that 4 references, oh, it's like it gets 6 points. Whereas this one, yeah, everything that hub 3 cites gets 5 points. Everything that site 1 references gets 4 points, and everything that site 2 references gets 3 points. So now we have a new authority vector. So the greatest authority is number 1, and then number 3, and then number 4, and then number 2. Okay, here's a way we can calculate this. A1 is A transpose times H1. Okay, so we end up with this. And so in this case, as we've seen, the most relevant sites, the 14, the 10, the 9, and the 6. So again, this can be the formula for calculating A1 from H1. So let's continue the process. H2 is A times A1. A2 is going to be A transpose times H2, etc. H3 is A times A2, blah, 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 blah. So thus, A1 is A transpose times H1, and H1 is A0. So let's replace A0 with this, and this is our formula for A1. Similarly, A2 is going to be A transpose times H2. We already know what H2 is going to be. H2 is going to be A times A1. And so we plug this in for A1. Oh my goodness, are you lost yet? So again, this is going to be A transpose A times A1. But here's our formula for A1. We just saw a moment ago, this is our formula for A1. So let's plug that in for A1. And notice what we end up with. A2 is going to be A transpose A squared times this vector. Ho-ho. Now notice that A1 was A transpose A times that same vector. I think we're onto something. Similarly, A3 is going to be A transpose A cubed times this vector, and in general, A sub n is going to be A transpose A to the n times this vector. That's awesome. To determine the best website, the search engine calculates A sub n for a large value of n. For example, A sub 20 is looking like this. So the most relevant sites in order of relevance are, now be careful, it's easy to look at this and say, wow, 9.43, that's pretty big. Yeah, but look at this. That's 10 to the 14th. The others are 10 to the 13th. So this is the most important one. It would be number 1, and then comes number 3, then comes number 4, then comes number 2. Yep, 1, 3, 4, 2. The sites would be listed in this order in the results of the search. By the way, here, as of earlier this year, February 2020, the global search engine market share looks like this. Holy cow. Google dominates with about 93% of all searches. Bing, Yahoo, Baidu from China, Yandex from Russia, and DuckDuckGo, one that I like because it doesn't store your data. Oh my goodness, those are distant competitors.